In this video, I'm going to discuss about concept of isostasy given by Sir George Airy. Before that, we have to understand what is isostasy all about. We see a lot of different kind of land features on the earth with varying magnitudes, like mountains, plateaus, plains, and valleys, and deep ocean trenches, etc. But there is balance is maintained between these land features. If this balance is not maintained, that will may lead to tectonic activities. So this kind of mechanical gravitational equilibrium between the upstanding parts and the low-lying basins on the rotating earth is called isostasy. While studying isostasy, many people came up with different opinions as were they studying the Himalayan mountains in the same latitude, but they could identify a variation in gravitational deflections. So this led them to give some their opinions. Some said Himalaya is hollow, and some others said it's not hollow. It is made up of a low density rocks in the upper part and a higher density rocks beneath. So many opinions came up during that time. Sir George Airy also put forward his opinion through this concept. This is based on the principle to flotation. So this theory is actually based on a law of Pascal's. So this is similar to the last Pascal's. What are the assumptions put forward by him? Where the inner part of the mountains cannot be hollow. Sial is floating in Sima. So this is Sial. So this is Sial. Sial is Sial. This is Sima. This is Sima. So here the Sial is floating. Sial is floating on Sima. Relatively lighter material is floating in the substratum of denser material because Sial is made up of a less dense material and Sima is made up of a more dense material. The Himalayas are floating in denser magma with their maximum portion sunk in the magma like a boat floating on the water. Upper crust lower density and the substratum with higher density. One part of the crust remain above the substratum and 9 part of the so he said here the 1 part of the Himalaya is above the substratum, the 9 part of the Himalaya is below the substratum. The ratio of freeboard to drought is 1 to 9. Analysis. When we analyze this, we have to assume that height. If we assume that height of Himalayas to be 8,848 meters, root of a Himalayas will be 9 times more than that. That will give you approximately more than 80,000 meters, which is 8 kilometers, 80 kilometers. And if the land column is big, a large part would be submerged. If the land column is big, large part would be submerged, and if the land column is small, smaller part would be submerged. So if the land column is big, the submergence will be more. If it is small, the submergence will be also is less. This is what the analysis shows. So let us look and understand through some example. He says that uniform density with varying thickness. So he took a uniform density wooden material and with varying thickness. So the length of these wooden boards are different. So and their thickness also is different. But the thing is they are uniform. They have uniform density. The length of this board is more, so it is submerged more. The length of this is less, so it submerged less than this will compare. So likewise he says that uniform density with varying thickness. So depending upon the length, the submergence is dependent. So according to Airy, the density of different column of the land remains the same. So different column, the density is same, but the thickness is different. Like mountain, different column. For example, we'll take the mountain as a column and plateau as a column, plains as a column. Density doesn't change with the shape of the landform. So he's saying, so if we mountains have like this shape, tableland has shape like this, plain has shape like this. But he says density won't change with the shape of the landform. So continents are made up of rocks having uniform density. Is saying that continents are made up of rocks having uniform density, but their thickness or the length varies from place to place. So depending upon the place, the density, the the rock density is same, but the continents are made up of rocks having uniform density, but their thickness or the length varies. So because of the length variation, we get different kind of platforms like mountains, plateaus, plains, etc. So this is how he is explaining. So if the wooden board length is more, the submergence is more. The wooden board length is less, submergence is less. But we have to understand that the density is same. So he is explaining in his concept with uniform density with varying thickness is the main concept of Airy's theory. And what are the evaluation of this theory is, if we accept the freeboard to draught ratio to be 1 to 9, the Himalayas would have longer route of lighter material beneath that would melt at greater depth due to the higher temperature prevailing there. Because 80 kilometers is such a greater depth, the temperature pressure will be very high, so this would have melted. But many scholars agree with the concept Sial floating on Sima, because the Sial, the upper rocks of the mountain Himalaya, so upper rocks have a lesser density while comparing with the lower rocks. Lower has more density than the upper rocks. Upper rocks, this is the lower rocks. Lower has density more, but this have density less. So he is saying that, so when we identify these findings, so we can agree with this concept that Sial floating on Sima, but they are not accepting the root formation in his theory, that Himalaya has a big huge root. This concept couldn't be accepted by them.